Question? Here we have the region S bounded by y equals to 2x. Y equals to 2x is a straight line with slope 2. Y equals to 8 minus x squared. Well, that's going to be upside down parabola with y-intercept 8. And then the x-axis in the first quadrant. So the one that's bounded by this one and the x-axis in the first quadrant must be this one. And it says we want to rotate that region S around y equals to -2. So here's -2. And we're rotating this around here, just like that. And the resulting picture must be something like this. You have like this one, as it rotates around, it's going to create some bowl-like thing, but the top will be not there, right? The top won't be there. And then inside, because there's like a space between these two, that's also going to create a circle in there, which is not there. And then the picture will be something like this. Okay. So that's the three-dimensional object we're trying to find the volume of. And you really want to work hard to picture it before you do anything. Okay? Don't try to be like, oh, it's too hard, let's just figure out how to get the answer without picturing it. That's the bad idea. Don't do that, okay? Always try to picture it. Okay, once you picture it, then you have to decide which way you should cut it so that the cross sections become washers. So should I cut it horizontally or vertically?
Horizontally.
Horizontally, right? It has to be horizontally cut so that the intersection will look like washers. And we want to find this volume by saying volume is what? Integral of?
Integral of dv.
dv. The universal formula, which always works. But dv means different things depending on which way you cut it, right?
The thickening in the y.
Yeah. So this washer, if I draw that washer, this by itself doesn't have any volume. The volume of a flat object is 0. So even if you add them up, it's still 0. But the great idea of calculus is that there's something that's very close to 0, but not 0. Those are called infinitesimals, right? So if you thicken this thin plate washer ever so slightly by dy, so that now it has a volume, and then if you add them from base to top, then they're going to start having the volume, which will give us the volume that we want, okay? So the idea is that we need to integrate this by saying pi times, let's call the radius of the big circle as capital R, radius of the small circle as small r, so that if you do area of the circle pi r squared minus pi r squared, this is what you get after factoring the pi out, and then you have dy. Okay, at this point, there are two more tasks that we have to figure out. One is we have to find the bounds. The other is we have to find capital R and small r as functions of y. Right? The reason you want to figure out whether it's dy or dx is so that you can figure out if you want the function of x or function of y. Right? Okay. Let's do the simpler one first. Let's look at the bounds first. I think that's easier. The bounds are, since we have dy, we have to figure out the smallest value of y and largest value of y. The smallest one is easy. What is it?
0,
0. It starts from here, right? Y coordinate tells you up and down, and the lowest point in this region is down here when y is 0, right? But then as you go up, you see that this is the highest point that y can reach, and we have to figure out where that point is, right? So let's figure that out. That is the intersection of y equals to 2x and y equals to 8 minus x squared. And we can find the intersection by saying the two things equal to each other. So we write 2x equals to 8 minus x squared. if you move everything to the left side, it becomes x squared plus 2x minus 8 equals to 0, so that the thing factors as x plus 4 times x minus 2 equals to 0, so that you get x equals to negative 4 and 2. But because the point of intersection that we are interested in is in the first quadrant, they do meet at the third quadrant, right? But that's not our concern. We are only working in the first quadrant. So we're looking at this x equals to 2. Now when x is 2, what's the y coordinate?
Can't you just plug into one of them?
Yeah, you just plug into one of them. So you just plug in here. Y is twice of 2,
4.
so it's 4. So we know that this point here is 2 comma 4. And therefore, what are the bounds?
0.
0 until 4. That's how you determine the bounds. Okay. Yeah. Yeah, it's easy to think that it should be square root of, oh, it should be 8 or square root of 8, but those are not true. Okay, next we have to figure out capital R and small r. And remember, we're trying to find these as function of y. That's the important part.
So we can rewrite this, but don't we have to factor in the negative 2 before we get it?
So the question was, don't we have to factor in the negative 2? I don't understand what your question is, but let's just continue, okay? First of all, we need to solve both of these bounds as function of y, right? This is y as a function of x, and that's no good because we have d1. We better have x as a function of y. You see what I'm saying?
Yeah, my question was, so like, when we get them in the functions of y, then later when we find the r, we have to add in the negative 2. Could we do that?
So we'll get there later, and I'll do it a little differently. What you're saying is right, but I want to be more systematic in there, okay?
Oh.
So wait for that. Okay, so you have y equals to 2x, which if you solve for x, you get x equals to y over 2, right? Also, y equals to 8 minus x squared. If you solve for x by moving the x squared over here and y to the other side, you get x squared equals to 8 minus y, so that x becomes plus or minus square root of 8 minus y. And we only take one of them, which? This is actually two functions, right?
When we take the positives, that's when
We only take the positive. Why?
this is where the positive quadrant.
Because we're in the first quadrant, x coordinate should be positive, right? So we don't take both, we only take the positive one.
So if it was in the fourth quadrant, we would take the negative.
Oh, that's a good question. If it turns out that we have some region on the second quadrant and we are rotating around something on the positive, then we'll be taking the negative one. That'll be more challenging one.
What do you mean by do?
Yes?
No, nothing.
Okay. All right, so now what we do is we have to figure out what capital R and small r is in this picture. And think about the following. If you have, maybe I should be using red. This is the center of rotation, and you're revolving this around and this around, right? So when this curve gets rotated around -2, that's going to create the capital R. Do you agree? Okay. And then this straight line gets revolved around x equals to -2, it's going to create the small r. Okay? I don't know how better I can say this. You really need to look at the picture and think through, or else you're not going to understand what I'm saying. Okay? So make sure you focus on the board and you agree with what I just said. Okay? So what is capital R? Is this distance. What's the small r? It's this distance. Get it? Okay. And therefore, because we're talking about horizontal distance are calculated by right minus left. Okay. Vertical distances are calculated by
Top minus bottom.
top minus bottom. Okay. These are very important things. Okay. So some cases you're going to do right minus left. Some cases you're going to do top minus bottom. And you determine that by drawing the picture, not by applying some formula. Okay? All right, so we're going to do right minus left, and then the right one, which of the equations here, everything on the board, describes this curve here?
The y equals x minus x squared.
It's this one, right? But we don't want to use this. We want to use it in
Y term.
this form, where it's a function of y, right? So it's really from x equals to negative 2 to x equals to square root of 8 minus y, because it's the distance from x equals to negative 2, this is x equals to negative 2, until x equals to square root of 8 minus y. X equals to square root of 8 minus y. Are you following so far? Okay. And therefore, because this is on the right side, that's on the left side, we're going to do right minus left. So it's going to be square root of 8 minus y plus 2. Yes?
Will you get the same answer if you did it the opposite way, or no?
If you did this minus that?
Yeah.
Yeah, okay, that's a good question. Well,
It's not commutative.
no, the thing is, because it's squared, it doesn't matter if you do this minus that or that minus this.
Okay.
Yeah. For at least for volumes, it doesn't really matter where if you do right minus left or left minus right. What does matter is when you apply these things for areas, and we are also going to do some mass of objects as well. For those problems, if you do left minus right, then you're going to get a negative value of what you want to do. Okay? So it's a good habit always to stick to this either right minus left or top minus bottom. Always use either one of those two. Okay? And you want to be systematic here because it's already like I'm asking a lot, right? I'm asking everyone to look at the picture, think through. It's not so simple here, it's very complex. So if you can make some parts of this to be more systematic, then you don't have to burden your brain too much.
Sorry, just to like
Yeah.
add on to that, when you're saying top minus bottom, did you mean on the graph?
On the graph, there's like an equation describing the top portion of the picture,
Yeah.
another graph that's bottom of the picture.
Yeah.
So
this
we-
equation, the top one would be the parabola. And
Yeah, for this,
bottom one.
well, I mean, if we had something like this portion, rotated around some object here, then the top will be the parabola minus this one.
Alright.
That'll be a different problem we can work on if we wanted to. But we're doing right minus left, and therefore we're doing this. Okay. All right. Tell me what r small r should be.
Y
Should be
over 2 plus 2.
From where to where?
From x minus 2, x equals minus 2.
To
X equals y over 2.
y over 2. Right. Yeah. It's from this one up until you hit this curve, right? Start from here until you hit there. Okay. So that gives you y over 2 minus negative 2, which is y over 2 plus 2. Okay, so we can now write down the integral in an integration ready format, 0 to 4 pi capital R squared minus R squared dy. And then we can plug in. Oh, I just copied this without changing. Oh, sorry. Capital R would be square root of 8 minus y plus 2 squared minus y over 2 plus 2 squared dy. And now we actually have to calculate this. Let's pull the pi outside. Square of the sum is square of the first. And then you have to double the product. And then you square the last one. And then minus, squaring this with, again, square the first one. So it'll be y squared over 4. You have to double the product. So if you multiply these two, 2 and 1/2 will cancel, and you double it, it'll be 2y. And then square the last one, which is 4. So what is that? That's pi integral from 0 to 4. You have negative y squared over 4 as the highest order term. And you have minus 2y and minus y, so that's minus 3y. 4 and 4 cancel, so you get 8. Oh, but there's also this square root, so it's 4 square root of 8 minus y plus 8 dy. So let me erase here to continue the calculation. It'll be pi times negative y to the third over 3. 3 times 4 is 12. Minus 3 over 2 y squared. So I guess I want to say a little bit about integration of square root of 8 minus y dy. This is like integral of negative 1 times y plus 8 to the 1/2 power. And you remember this formula, integral of f of ax plus b
1 over a.
dx gives you 1 over a capital F ax plus b, right? So that this negative 1 is acting like a, so that gives you 1 over negative 1 in front. And then once you have that, then you can just treat this like a big X. Right? And x to the 1/2, how do you integrate x to the 1/2? You add 1 to the exponent, which is 3 over 2, and you put the reciprocal in front. 2 over 3. Again, 8 minus y to the 3 over 2. So that's the integral, okay? So I'm going to write that here. Negative, oh, but there's a factor of 4 there, so 4 times 2 is 8. So negative 8 over 3, 8 minus y to the 3 over 2 power plus 8y. And you have to plug in 4 and 0. Okay. So now what? 4 cubed is 64. Oh, but one of the 4's will cancel, so it'll be 16 over 3. 4 squared is 16. 16 divided by 2 would be 8. 8 times 3 is 24. 8 minus 4 would be 4. 4 to the 3 over 2 power is 2 squared to the 3 over 2 power. So these multiply, so it's going to be 2 to the 3rd power, which is 8. So that's going to give you 8. 8 times 8 is 64 over 3. And then 4 times 8 will be 32. Oh, wait, just a minute. Yeah, it should be fine. Okay. Minus, now when you plug in 0, all of these will give you 0 except this one, right? This would be negative 8 over 3. 2 to the 3rd power to the 3 over 2 power. Because 8 is 2 to the 3rd power. Okay, this will be negative 80 over 3, 8 minus 80 over 3, 24 minus 80, 56. Okay, so it's going to be pi times negative 56 over 3. And this is 2 to the third power, 9 over 2, 6, oh, let's do it like this. 9 over 2 is 4.5, 2 to the 16 times 8. So it'll be 128 over 3, oh, plus. Minus is plus. So that's what you get, and therefore the final answer is pi over 3 times 128 radical 2 minus 56. Phew, that was harder than I thought.
And we're gonna